Hey, hello, 102 students. Looks like I got a couple of you asking here about number 28. So let me read it and go through this. It says here, your right rear tire has to support a weight of 3,000 newtons. Normally, the contact area of the tire with the road is 200 square centimeters. If the pressure in your tire is suddenly reduced from 32 pounds per square inch to 16 pounds per square inch, what must be the new contact area of your car? All right, now, there is, like a lot of these problems, an easier way and a harder way, so there are multiple ways of doing it. So I like to say that, any correct way you do it is fine. But if you'll notice here, they gave us what you're supporting, the weight of the car. I'll call that the force of 3,000 newtons. And you'll notice here that then they gave us a contact area of 200 square centimeters. Let's see. They also then give us a pressure of 32 pounds per square inch. Now, all of these units are a mismatch. Or let me write it this way. Pressure is force over area. And the standard SI units would have force in newtons, so we've got that, but it would have area in square meters, and we don't quite have that, although it's not too hard to convert from square centimeters to square meters. But nonetheless, you're probably tempted to do that. To make matters even worse, though, is the standard SI units would make this into a Pascal, a Newton per square meter. So if you use newtons here and square meters here, you get Pascals. And this is not in Pascals. Now, again, there's a conversion factor, so you can look it up and convert everything into units that probably would make you feel comfortable. And again, nothing's wrong with that. But I think this problem is really kind of twofold. First is just, can you solve it? And then the second one is, can you solve it in terms of proportionalities or beyond just what the base units are? And here's what I mean by this. If I rearrange this equation and say force is pressure times area, what this is really saying here is the amount of force that you get to support your car is a combination of how much pressure and how much area. And if you multiply those two together, you will get a certain number. Now, that number is supposed to come out to be 3,000 newtons. But without worrying about that, you might say something like this. If I have some initial pressure and some initial area, and I multiply it together, I get some force. And the reality is then, if something changes, which in this case is the tire pressure, they're saying the tire pressure drops to half as much, you would now have a final pressure and a final contact area equaling that same force. And that's the kind of the key here to this problem, is to realize it would be this same force. You got to support the same weight of the car, regardless of what the units are. So if you convert everything into SI units, then this has to come out to be 3,000. But whether you convert the units or not, it's still got to be the same force. So maybe a little more advanced way of doing this problem is to not really worry about what unit system we're in and what we're using, but just to say that there is a mathematical connection between pressure and area, and then pressure times area. Or put another way, if you take the initial pressure and divide it by final pressure, that would be the same as final contact area divided by initial contact area. And this is what I mean by a proportion. So the idea being is, if you change the pressure by a certain proportion, the area would change by that same proportion. Again, regardless of what units you are using. So in this case, the initial pressure is 32 psi, and the final pressure is 16. So that's a factor of 2. So in other words, coming back up here to this problem, they're saying, look, if the pressure drops by a factor of 2, the area has to go up by a factor of 2. Because again, that's what we mean by force per area. We're having less force per area. So we've got to have more area to make up for that in order to lift up the same amount of force. So this is the key to the problem. It's a factor of 2. Your final contact area then is needing to grow by a factor of 2. They already told us that the initial here was 200. Now, that's in square centimeters. But again, not worrying about the unit or converting the unit, we just got to realize it's got to double. So there it is. 400 square centimeters would be the answer. It would have to change by a factor of 2, and it'd have to increase by a factor of 2. Since pressure went down by a factor of 2, area would have to go up by a factor of 2, and so there's no need to worry too much about what the exact units are. That's probably the best way to handle this problem. All right, good luck to you.